if we look at our situation, ordinarily speaking, if we could run all the water that was available to our crops through the plant to produce grain or forage, we would have a linear relationship between the two. But that's not the way things are in real life, because we're not 100% efficient in putting water on the soil. But if we were, whatever efficiency we're at over here, if we did get a little bit more efficient, situation would be that we could put on less water with their irrigation system and get basically the same yield. And so in terms of water conservation, we'd be looking at the difference between these two applications. Now, start with the center pivot selection of the appropriate sprinkler package for the field. It gets to be pretty important. There's a large number of different kinds of sprinklers we can select from these days. And so it's not necessarily a one-size-fits-all, and you might could find some different things to look at. If we don't do a good job of selecting that sprinkler package, is one of the biggest things that can be a negative in terms of water application efficiency, is the potential for runoff. And as we get these nozzles closer and closer to the ground, we're applying the same amount of water in a much shorter period of time, and so we either need to have the soil have the ability to take that water in directly, or provide some means of storing the water on the surface until it does infiltrate. I mentioned surface storage. You know, most of the time we're going to have some surface roughness that's out there that water is going to pond up on or in. And on flat soil conditions, we have considerable amount of storage possibility. If we take the same depressions and put them on a slope, however, now we're going to have somewhat limited storage capabilities, and we potentially have runoff issues. Subsurface drip is a type of water application systems that, if we do manage them appropriately, we can conserve 15 to 20% of the water. And the reason is that with all of our sprinkler devices that we're currently using in Nebraska, we wet the whole soil surface, number one, and we wet the crop canopy, number two. Those are two things that do not happen with a subsurface drip. We're putting the water below the soil surface, and so the only evaporation loss off the soil surface or even the plant that we get in a SDI irrigated field is when it rains. Okay, so in general, there's a couple things that happen here. We can conserve this water because we don't have the soil evaporation loss, but because that top portion of the soil tends to dry down because we're not applying water there, it makes better use of the rainfall that we get during the growing season. So we don't have water that's maybe passes through the profile quite so much with these systems as well. General installation is going to be one drip line for every 2 rows of crop, and you tend to want to get equal access for the crop on either side of these to the source of water. That's going to go upward a little bit, outward a little more, and downward for the most part. So the roots tend to grow around this once they go into the season. Most of these installations are probably going to be somewhere around 14 inches deep, maybe 16 inches if you want to go there. The idea is to get it below the tillage zone, whatever you might want to do on the surface. Typically, you'll have down the drip tube line here, there'll be an emitter that is dripping water about every 18 inches down the row. So that's kind of the spacing between them. In a lot of our installations, we may want to think about having pressure compensating emitters on them, depending on what the terrain's doing out there in the field. If we have a little bit of elevation change in the field, sometimes we can't always have the drip lines going downhill or downslope from the source, and so we may need to have pressure compensating emitters. That puts the cost, potentially up in the $1,500 an acre range. So they're not inexpensive, but they do conserve water. And for small, odd-shaped fields, less than 80 acres in size, SDI tends to be as economical or more economical than a center pivot. The purpose of this is really to say that we've got soil monitoring equipment available from a variety of sources now, some of which you can access through your center pivot panel, and some that will be accessible there in the not too distant future. And basically, these ones that are on the right are are sensors that are capacitance-based probes, and they would be installed by the provider and removed by the provider, but it's an annual installation kind of thing. And you can access then by internet or cell phone the output from that. This is some work that was done by Danny Rogers and his crew at Kansas State, and it depicts a scenario that's kind of an interesting one, in that the front end of the system in zone A over here, that's the kind of variation that you're going to expect and catch with the type of sprinklers that we have out there. So this is pretty normal on the front end, the first 850 feet of the system. You see part B here is a leak. There was a gasket that was leaking on the tower, and so those are the kinds of things that should be obvious fix-its. What's less obvious, and probably most people wouldn't even know about, and this person didn't until they tested this, is that there were two spans here where the sprinklers were flip-flop. The nozzles that were installed here should have been here, vice versa. So here we have color-coded nozzles, numbers on the side of them, and they still put them on backwards. So weird things happen. This is not the norm, and it's not something that happens all the time, but I think it's something worthwhile spending a little time walking along the system to verify that at least the color nozzles are appropriate in each one of the positions. Now, the producer on this system took it upon himself to change the operation of the volume gun as well. So it was making a more of a circle than it was originally designed to do. So as a result, they were getting more water applied out here than what they were supposed to. And less of the water was going out further out outside the pipeline. I'm switching gears here quite frequently, but moving into some of the more panel, center pivot panel, and what we might be able to do with them. So if we have an operation that has pivots distributed over a 5 or 6 mile square area like is shown in this particular drawing, how do we manage all these systems? We send somebody to that field several times a day to make sure they're operating, or do we have some way of monitoring those systems from a cell phone or a computer system at a central location? So if we have the panels there, how can they contribute? Well, this morning we were coming down, there were some systems running, and we just had the rainfall come through. They might have been putting fertilizer on, I recognize that, but the opportunity would be there with the cell phone on the house, shut that system off when it rains rather than having to go out physically and do it. Because I'd be like most people, and certainly 2 o'clock in the morning, a good rain comes through, I'm not going to spend the rest of my day going around turning them off. They'll run until morning. But you can do it by phone, it's more apt to get done in a timely manner. Change speed of travels for the crops and the soils you might have out there in the field. We can do that. We have been able to do that for a number of years. We can do more of it now than we used to be able to. We can find out when something's wrong. If we're on electric load control, we can have an automatic restart based upon a certain time of day, and we get updates. Each one of the manufacturers of center pivots has the computerized panel. You all know that. They're capable of doing a lot of things, and we'll talk about that. There are some aftermarket things that you can put on. In this particular case, the AgSense system is something that you would place this controller system on the last tower. It has GPS capability, and it communicates from the last tower location with the pivot panel to change speed of travel and a few other, monitor the system, that kind of thing. And so we can do a lot of things with some add-on kind of capabilities here as well. I mentioned the computer systems that are there. Each one of the manufacturers have that capability, and by virtue of the color of the machine or the location here, you can get an idea of what's moving, what's not, what direction it's going in, what the speed of travel is, and all that kind of stuff. So there's a number of things that you can do just by with these software packages, and they don't give them away. There's a cost associated with them, but they do provide some value, particularly if you have systems that are strewn over a fairly large area. Each one of them has the ability to deal with end gun operation on and off. They've been able to do that for a long time. It's easier to do this, a setting for those kind of things. auxiliary control, if you want to turn it on and off, an injection pump where you're putting fertilizer on corn, you don't want it on soybeans. You're chemigating on one crop, you don't want it on the other. Those kind of things can be done with the panels. Adjust to different crops in terms of speed of travel. And then we're all going to more and more capability of providing, at the end of the year, some idea of what was put on and when it was put on that particular field. And over time, as time goes on, we may, in fact, find this valuable in terms of knowing what was done when, if something happens to come up, that somebody asks you whether you happen to be applying a herbicide on a certain day or something. You have a record of that. Communication links that we've been talking about here a little bit. Radio is one way in which one can do this. These are line of sight radios. And so, we might have to have a repeater at various places to get communications to all of the field sites. It is one way to communicate with the system. The other approach is the one that Rinke has taken, and they're utilizing a satellite radio rather than just a line of sight radio. And so from the field site, they go straight to a satellite and go through to a gateway system down on the Earth's surface, and then basically back through, and so you can access through a phone call or the internet on a computer system back at the office. The AgSense system is a cell phone based, and maybe mentioned this already, but they have they're able to monitor and manage or control different components on the farm system. The center pivot is just actually an add-on here that they've added on, but grain bins, storage facilities of various sorts, animal buildings, a lot of things can be controlled or monitored by the system in the cell phone. But the idea is that you've got these panels that you can access on the smartphone that have the capability of telling you what's going on out there in the field. And you can do that from anywhere, anytime. Soil water monitoring equipment, there's some work going on, and one of the things that all the installations that we have, for the most part, are not permanent. They're installed and removed every year. Right now we're looking at, most of those installations are just one spot in the field. And so we have always had some questions about how many of these we might need out there in the field, but there's been some work done by the ARS group up in Sidney, Montana, and in Washington State, looking at some of the real-time monitoring control systems. And the basis for them is a wireless technology that would transmit the information from a point in the field to the pivot point or to some receiver that might be a line of sight away. The other thing that's going on is that the ARS group down in Bushland, Texas, have been working for a number of years with pivot-mounted infrared thermometers. So as the system's going around, this little multispectral and thermal sensing device is recording information about the crop as it goes. In this particular case, the water is being applied in a LIPA mode. If we were doing this in most of our conditions up here in Nebraska, this device would be mounted so that it would sample something quite a ways out in front of the pivot, so that it might even have to have a cantilever arm out there to get away from the water pattern as the system is going around. We do have a fair amount of information on our website that covers some of these kinds of things. Water.unl.edu